let's give you a kind of big picture of what we're going to be doing today. We're going to finish off chapter 2, the bell-shaped data stuff, and we're going to start chapter 3. And there's 2 sections in chapter 3, and we're going to begin looking at what are called scatter plots and correlation. And here are some of the topics within that we'll be doing. So that's kind of what we're going to be doing today, finishing off chapter 2 and getting started on 3. And for the rest of the week, we're going to be dealing with chapter 3 stuff, which is linear regression. That's its big name. This is one piece of linear regression here. And when we're finished that, we'll be ready for our test. And our test will be on Monday, and you'll turn up to class like normal. And the test will be a PDF that you'll open up in Canvas, and you'll write the answers down. Okay. So let's do this fella, bell-shaped data. Now, a lot of data has that shape to it, bell-shaped. And let's suppose that the mean is, well, I'm trying to use a number here, 400. We call that X bar a lot. And the standard deviation, capital S, and the standard deviation, actually, can I change that to 500? Right. And the standard deviation is 100. Right. Now, if I wanted to do one of those empirical diagrams, 500, and then you go 1, 2, 3 standard deviations. So 600, 700, 800, and 1, 2, 3 going back the way, you go 400, you go 300, and in this case you go 200. That's pretty much what you've done before. So what we're going to finish with, well, 2 sets of questions. Suppose someone got a score of 400. We're going to find the Z-score. Now, the Z-score is the data, take away the mean over the standard deviation. That's the formula, more English-like. I like that formula, so that's what I'm using. So it's 400 because that's what the data is. The mean is 500, and the standard deviation is 100, and that comes out as a very nice number. You get a Z-score of -1. Okay. Now, the second question is, we're going to use SALT, so I'm going to turn over to that in a few minutes, but we're going to use SALT to find the approximate proportion of people who had score, how do they phrase it, falling below 400. Okay, so if you imagine in my picture here, we're basically trying to find out what percentage of the data is that shaded area, right? Less than 400. And we are going to use SALT to do that. So let me stop sharing this and jump over to the screen. And oh, 2 people coming in, here we go. Now, I don't know if I can make that big. I probably shouldn't. Right, so here's the question that I just copied. I already got the Z-score, so you're just going to type in what the answer was, which is -1. And now I'm going to use SALT. So when I click on SALT, I'm looking for below 400. So let's see how that works. Now, that's a pain in the butt, but I'll try it. Can you see a diagram, or will I have to go out and in again? Can you see a bell-shaped curve thing going on here? Oh, it worked. Cool thing. Okay. Now, normal distribution, leave it alone, right? The mean was 500. The standard deviation was 100. What proportion of people are less than 400? So do you see how I filled them in? Maybe I should make this a little bit bigger just so you can see the numbers that I typed in.
Maybe I missed something.
Right.
I thought you said standard deviation was 100.
Whoa, it is 100. What did I hit that for? There. Mean 500, standard deviation 100. Make this guy 400. So what proportion of people got a score? X means a score of less than or equal to 400. Can you see over here what the picture looks like? And the answer you're looking for is that guy there. Do you see it does it for you? And which is what? 0.15866. So I'll copy that. And I'll type in that number. Okay. So that's basically how you answer questions like what proportion or less than things. Right, I got this guy back again. Let's shrink the picture up a little bit. I want to see the whole diagram. Right, can you see the normal curve? That's what we call the bell-shaped curve, another name for it, this normal curve. Suppose I'd like to know how many people got less than 230. Right, that's tiny. What would that be? 0.3%? I'd prefer the proportion to be a percentage. I think 0.3% is easier to understand. How about 482? What's that about? Roughly about 42.8%. You can also find out bigger than something. Now, do you notice that little dot is left tail? Because that's what we call this. This is a left tail picture. If I do a right tail, right? See this thing? I can now tell you what percentage, what proportion of people got a score, I don't know, bigger than 620. And the answer is about 11.5%. All you need to know is the mean and standard deviation and have this piece of software handy. Can't you tell what percentage of people got bigger than whatever you like? Okay. Let's suppose this professor says, if you get more than 800, I'll give you an A. I wonder what percentage or proportion of his class would get an A. Oh, he's pretty stingy. 0.1%, that's probably nobody then, right? Okay, let's suppose he changes his mind and he says, okay, that was a bit rough. I'll do it with 700. Well, won't only 2% of his class get an A? Right? So do you see that you can, if you've got your test, and have you ever heard them use the saying grading on a curve? Ever heard that phrase? And you're wondering, what's the curve? That's the curve. So he puts all the data in and he says, I could pick this guy up here, right? And I could tweak it. You know, I could decide 650, isn't it? And that's 6% of the cost. Yeah, I'm happy with that. I could change it around. Do you know if I put 10% in here? Do you see how it changes the number? And so I can now say an A is 628 or better. So it's quite useful, isn't it, that you can use a bell-shaped curve and this piece of software, and you can find what percentage or proportion of people got bigger than some number got less than some number. You could even if you wanted to, but we're not going to, between two numbers. And you could also turn it on its head and say, what score do I need to do so that 10% of my class get an A? Right. And if you want to do it that way, you put the 10% here and you read the answer up there. Are we good with that? Have we got any questions? We feel happy? Can we call this done then? Thumbs up, I'm going for it. I like that. Let's go and start chapter 3, where I'm going to begin with a fair amount of notes. First thing we're going to look at is called a scatter plot. And I'm going to collect some data here. So we need some volunteers to give me some data. And from that data, I'm going to make a scatter plot. I can make my table as big as I like. Okay, so you're going to put into this data your mum's age and your dad's age, right? And we're going to create a scatter plot from that data. So if you don't know, you can kind of guess, we'll allow that. And no, your mum isn't 25, even if she tells you she's 25, right? So I'll take some volunteers. Give me a mum and a dad.
My mom's 49 and my dad's 46.
Next one.
Someone put in the chat that their mom was 50 and their dad is 48.
Thank you for doing that. I can't really see chat. That's brilliant. If anybody does that, do that again in the future for me, please. Okay, I need at least 3 or 4 more. So if you can pick your uncle and your aunt.
Mom 67, dad 70.
Okay, you can actually chuck in anybody you know. So if you want to do your brother and he's married, you can do that as well, right? I guess. I just need 3 more numbers and I'm happy. Give me 3 more.
My mom's 48, my dad's 56.
Keep going. 2 more. Anybody else want to share? An uncle, some, whatever. Okay, I'm putting in my sister. Oh, go.
Okay,
Say again.
61. Sorry.
Can't hear you. Very quiet. Try again.
Mom 58, dad 61.
Okay, one last one. I'm going to pick my sister. I've got lots of sisters, but I'll pick the one that's closest to me. My sister is 69 and her husband is 71. So, what does a scatter plot look like? Well, you have an x-axis and a y-axis. And mum's age is going to go there. Because typically, whatever's in the first column is the x's. And dad's age is going to go here. And what do I need? I guess I can start at 40. So there's 40. Make that 50. Make that 60. Make that 70. Make that 80. And what do I need? Yeah, 40 will work both directions. Make that 40. 50. 60. 70. And so on. And mum is 49, dad is 56. 49, 46, right there. And next one is 50, and 48, 50, 48, 50, out here. 67, 70, 67 is about here, 70 is about here, 48, 56, 48, 56 about here, 58, 61, 58, 61 is about here, 69, 71 is about here. Basically, don't you just plot points like coordinates? And that's what we call a scatter plot. So we're going to introduce some terminology that we use for scatter plots. And I'm going to come back to that one. But let's show you some examples of scatter plots. I'll just call them X's and Y's here. Do you see in this case, I'll do a little sausage around it. As the X gets bigger, so do the Y's get bigger, right? So the data is basically climbing uphill, right? When the data looks like that, we say it has a positive association. Our example here is quite steep, but if I chose a better scale, it might not look so bad. Would you agree that our data is positive association? Now, what does that mean? Well, it means something pretty simple. Typically speaking, is your mum's age is getting older? Is it your dad's age getting older? In other words, old people marry old people and young people marry young people. Not exclusively so. There are some really ugly, rich guys who have married really pretty young women. And there's no way in the world you're going to tell me it's because she liked the way he looked or his personality is so cool. I'm just saying that because my wife and me are now addicted to, oh God, I've forgotten the show, but I call it the Trainwreck Show, where there's a whole load of older guys marrying very young women, and it's a train wreck, but it is so fun. You know, watching train wrecks is fun. That's an example of it. They're an exception. So back to the storyline. Positive association. If you have data, and it can happen, and you do the scatter plot, and the data looks something like this, I don't think it'll take much imagination to figure out how do we describe this.
Negative association.
Thank you. I know it's a silly question, but I was still hoping for an answer. What might be negative association? Oh God, that's when the X's get bigger, the Y's get smaller, right? So as one goes up, the other comes down. So
Isn't that just if you made a best fit line, the slope is the relationship?
Yeah. Positive slope, negative slope, that actually comes in later. You're right. They're called associations right now, but later on you draw a line through them, the best fitting line, and the lines are positive and these are negative. I'm just trying to think an example one. You think it'd be easy, but my brain can't think of one. Oh, how about X is the age of your car and Y is what it's worth? Would you agree that at the beginning your car's worth a lot, and then 10 years old car and 20? We're not going to, talk about 200-year-old cars, but that would be a negative association, wouldn't it? The older something is, the less value it is. Now there is a third possibility, and you might think, how can you get a third one? Well, let me show you the third one.
Is it one that's not so linear anymore?
Yeah. I don't know how many dots I put in, but can you basically just see a big blob? It's not really going uphill. It's not really going downhill. It's not really going any hill. Or direction. Want to have a guess at that one? What that's called? And don't overthink it. If this is positive association and this is negative association, what kind of name would you give that one?
Is it no association from the first page?
You nailed it. Yeah. I like names to make sense, right? Would you give positive, negative, and no association? Kind of makes sense, right? Then, you know, they're not got weird names that don't kind of fit the world. Okay. So what we're looking at here are, how do you draw scatter plots, right? You collect data. The one we did wasn't a positive association when you did your mum's and your dad's age, but I could have asked you, you know, how old is your car and what's it worth? And if I plotted that, I might get data that looks like this, right? If I went and asked you, how old are you? And what's the last digit of your cell phone number? Would you agree that those two have no connection whatsoever? So you just basically get a random set of dots. So that would be no association. If you see an association, positive or negative, what that can sometimes mean, and often does mean it, that isn't X and Y somehow connected to each other, right? There's some kind of relationship that's making that happen, right? So we are very interested in scatter plots that look like these, right? We're very interested in that. We're not really interested in scatter plots that look like that, because basically doesn't that say the two things don't have anything in common? So there's no predictive qualities to them. You can't really do much with them. Now, let's focus on a different name. We know about positive and negative association. Right, okay. Skinny sausage, fatter sausage, big fat sausage. All three of those are positive associations, agreed? Right. We have another term that we like to use, and this term describes the strength of the association. So this guy is positive and strong association. Strong, the data is close together for the most part, right? Skinny sausage, strong. Fatter sausage, still positive, moderate. Right? Positive and a mod.
Correlation
Question.
of the best fit line help us with that?
It will. And this fella is positive. Anybody want to have a guess?
Weak.
You nailed it. Again, isn't it good that if they use words, it kind of helps you understand what it's telling you, right? So imagine I said, oh, I've collected some data. I can't be bothered showing you all the numbers of the table, but I collected some data here, and it was strong and positive association. Do you already visualize what it probably is going to look like? You don't know the numbers or the specifics, but won't it look something like that? Won't it be a skinny sausage? Now, it might be a steep skinny sausage, right? It might be not so steep, but it's still going to be a skinny sausage, right? And so having those terms allows us to describe in words what is essentially a picture, right? A strong positive association I kind of know what you're talking about. I'm not going to do the negative ones. Would you agree? The negative ones would look very similar. Strong, moderate, or weak. No association. Do you think you can have a positive, a strong no association, a moderate no association, and a weak no association? No. You don't use those terms when it's no association, right? It's just got nothing. And that's the end of it. Now, the next fella I'm going to look at is the term outlier. You can do a scatter plot and everybody pretty much fits inside the sausage, right? But it is possible that you might get an outlier. So an example of an outlier would be that guy down there. Would you agree that 99% of the data is inside the sausage, but there's a little guy floating out there like a sore thumb, right? Sticking out, awkward. Couldn't you have an outlier up here? Couldn't I have an outlier way up here? Oops, you can't even see it, it's that far up. But you might say, it's pointing the same way as the sausage, yeah, but doesn't the sausage really end here? And then there's nothing going on, and then there's a weird Bill Gates guy up there. So he counts as an outlier, he counts as an outlier, he counts as an outlier. So any data point that doesn't belong inside your main sausage, which isn't a mathematical term, but you know what I mean, that doesn't belong inside your main sausage, we will call those guys outliers. Are we comfortable with what scatter plots are and some of the words that we use to describe them? Positive, negative, no association, strong, moderate, weak, and occasionally we might even use the term as an outlier. Okay, bit hard to answer all those questions on the mum-dad one, but let's try it. Do you think it's got any outliers? No, right? So none of you have an, I don't know, an 80-year-old mum who's married to a 20-year-old. Well, that'd be kind of hard based on your ages, but whatever, right? So no outliers, positive. And the next one, I don't think I can answer truthfully, but do you think it's strong, moderate, or weak? Kind of hard to judge, isn't it? What do you want to go for?
Moderate.
Yeah, that's what my brain is telling me. But could somebody argue differently? I'm sure they could. When there's only a few data points, isn't it very difficult to do the strong, moderate, or weak, right? I'm going to have to waste this data now. But if my data looked like this, wouldn't it probably be strong? If my data looked more like, you know, filling in the whole sausage, that's probably more moderate, agreed. I can't really do weak unless I add dots outside my sausage, right? And it turns into a blob. So it can be a little bit subjective when you do moderate, strong, or weak. And one person looks at a scatter plot and sees moderate. Some other person looks at the same scatter plot and says weak. Any questions about that before we kind of move on? You feel comfortable about what we've talked about so far? Okay, if you hold on a minute, I have another guy to set up here. Yes, here we go. And we're going to look at some homework questions. Oh, darn it, I've got the answers. I don't want the answers, they distract the heck out of me. Okay, I think I got it now. Now, can I make that bigger? Will it rub out the words? Oh, good, good, good. Okay, so the first question one in this new section of homework is, for each of the following pairs of variables, is there likely to be a positive association, a negative association, or no association? And then briefly explain why you chose that. So the amount of alcohol that you consume and your performance on a test of coordination, where a high score represents better coordination. Okay, so x-axis, you drink a lot of alcohol. Y-axis, big number, you're really good at coordination. Bottom number, you can't scratch your nose, you miss it, right? Your coordination's shot. What kind of scatter plot would you expect to see there? Would it be going downhill, going uphill, or would it just be all over the place? That's our choices. Increase alcohol consumption, decrease performance. Wouldn't that be, I don't know what you, it's going downhill. So we call that negative, right? Now let's look at the choices. It's negative and that one's negative. But one of these gives a good reason for it. So let's look at the two choices. We expect a negative association since we expect the coordinates will decrease, that the coordination will decrease when the amount of alcohol is increased. Would you agree that's a good way of describing that? Now let's look at this one. We expect a negative association since we expect the coordination will increase when the amount of alcohol is decreased. Isn't that actually the total opposite of what it should be? So do you see that although we know that it's negative, isn't this explanation just false? That's not why it is, and this one is working. So you have to decide positive, negative, or no, and there's a good chance that there'll be two of them that are positive, and you have to figure out who's the right positive, or two of them are negative, and you have to figure out who the right negative is. The weight of a car and the number of miles per gallon it can go. So along the x-axis, you get heavier and heavier and heavier cars. And on the y-axis, how many miles per gallon, right? So 40 mile a gallon, 30 mile a gallon, 20. Do you see a negative like me again? Negative association, heavier, smaller miles per gallon, right? You would pick whichever one of them is. These are some more stories. There, we got a little picture. This figure for this is a scatter plot. Y is the average math SAT score way back in 1998, and the X is a percentage of graduating seniors who took the test in all 50 states and the District of Columbia. So every single one of those dots is a state. So let me pick a state at random. See that dot there at the bottom right-hand corner? When I'm going over it, it'll disappear, right? See that guy there? There's a state in America where about, 93% of the high school graduates took the SAT test. So evidently there's at least one state in America where virtually everybody takes the SAT, except for the dropouts and the people says, nah, I'm leaving school. I don't need to take the SAT. I'm not interested, right? So that would be 83%. And of that state, if you read horizontally, wasn't their average SAT score, well, it's a very hard scale to read, especially in my eyesight, but 480-ish? Would you agree it's roughly about that? You might argue a little bit about the number. So do you see how each dot represents one particular state? Now, looking at this data, positive, negative, or no association, what would you go with? Does that scatter plot
Negative.
make you think positive, negative, or no? I think I heard the answer. Could you say it again, please? I agree with you.
Negative.
Do you see it going downhill?
So are they
Is it
saying
going
that-
downhill?
Sorry.
What you're saying?
I was
Nakia?
saying I just wanted to make sure I'm reading it right. So they're saying the more people that take it, the lower the average score is. Is that?
Yes.
Am I reading? Okay. Okay.
You are
Thank
reading.
you.
You're reading that correct. Now we can maybe. Well, that's what you're reading, and that's what it's saying. So we have to figure out what the heck. Why would that be true? This isn't one of the questions, but it's a curious question, so I would ask it.
Because the schools,
You-
like in some states, like that schools that are it's mandatory, they have a different level of people. But in some states that people are just trying to go to college and might have a better level of test taking, they might are the ones that probably get the higher scores. The ones that are trying to college. It's weird. Some states make people take the test no matter if they're going to college or anything.
Yeah, it's just a way of them, I guess, grading the high school, right? If you have a high school and they all take the SAT and they get a really high SAT score, isn't that reflection on that school's got a lot of good students in it, or that school's good at educating, or whatever reason that is happening? And this is totally made up. I've no evidence of this, but
It a
yeah.
good representation of what it is actually like in real life, though.
Okay. So in this case here, what we're saying here is that if you make everybody take it, aren't you going to get a lower score? Because won't a lot of people who take the SAT not be that academically interested in doing well in it? I mean, you know, if you make somebody do something and they didn't want to do it, and they're going to leave school, you know, and go and, you know, work in a factory or something, right? The SAT is not any use to them. Can you imagine that they're not going to do very well in it? Wouldn't that bring the average SAT score down? Now, if you look at the other end, there are some states where only, 5 or 10% take the SAT. But I bet you that 5 or 10%, won't the vast majority of them want to go to college and university? So won't they more likely be the academic students? And because of that, won't their grades probably be quite high? Does that seem like a reasonable explanation of what the heck, how that happens? To give you an example, and then we'll leave this question because it is in my head. This is what they did in Scotland, and it's a total cheat, and they shouldn't be allowed to do it, but they did it anyway. You know how from time to time politicians get really uptight about education and they want to find out how good schools are doing, right? So even in Washington State, wasn't there a big push over the last 10 years of standardized tests so that you did one in your junior year or something? Wasn't
Yeah,
that? I can't remember the details, but
It's
wasn't
also
that
dumb because you have to pass the test to be able to graduate too.
right? So that's how they forced you to do it, right? If you don't take this test and pass it, you're in
Yeah, and
trouble,
if you
right?
don't
And so it was a
It's
mandatory
so
thing,
dumb.
really. Yeah. Is that still going, or they kind of petered that out a little bit of wishy-washy
It
now?
was still going until COVID hit, and then they stopped the standardized testing. But you need to have either you have to pass that test, or you have to take a college class or AP class and pass the AP test. It's dumb. It is really dumb.
I totally agree. So here's my story about Scotland. In Scotland, we had, I've told you before, we take exams for everything, right? You take an English exam and everybody in Scotland takes the same English exam, right? So we don't have grade inflation. But not everybody takes the exam. Some of you take English and you're so bad at it, your teacher says, there's no point you taking that English exam, you're just going to fail it anyway. And a lot of them say, great, because I hate English and I don't like taking English exams anyway. And so what happened was that the government was using those grades to figure out which schools were the best schools, right? Which schools were doing well, right? Getting high averages. And so what the school did, including my school, is they cheated. They went and made sure that only their best students took the exam. Now, what happens when only your best students take an exam? Doesn't your score for students who took that exam get really good? Classic example, when I was in 4th year, that's what we call it. We have year 1 to year 6, our high schools are 6 years. So when I was in 4th year, I was so bad at art and at technical drawing that they told me I wasn't going to be allowed to take the exam. Right? The school decided whether I could take an exam or not. I'd know if I wanted to, it wasn't happening. Why? Because I would have brought their average down. And in 5th year, I took art again, and I took tech drawing again, and I was still too bad at it, so they wouldn't let me take the exam. And difference, in 6th year, you can choose what to take and what not to take. So I took both exams, and I failed the art exam abysmally because I'm still useless at art, but I did scrape a pass at technical drawing. And of all the things I got grades for, you might think, because I am arrogant, that I was really happy about the really good grade I got in math, which I was. I was most happy about getting my tech drawing, because nobody had any. You were useless. You're never going to get it. You're never going to get it. And just because of that, I think I got motivated enough to just figure a way around it and get it. And there's something kind of satisfying about proving people wrong, isn't there? Okay, I was bad at art. I was actually pretty bad at English, but not that bad that they wouldn't let me sit the exam. So, a little story about me. Let's continue the quest here. Would you agree that this is a negative association then? Would you want to put on that strong, moderate, or weak? And that's a bit subjective here, but what do you want? David's doing moderate. That's what I think his mouth is whispering, right? Wouldn't argue with it. Would we all agree it's probably not strong? Right, so moderate or weak would have to work there. Now, I haven't used this term yet, so let me go and do it next. There is another term that I haven't talked about. I do not like the name that you're going to hear in a few moments. This data, I like this name, is linear. And that's the shape. Right? It's basically, can you imagine it's a straight line going downward, right? Linear. I don't know if I've made this obvious enough, so let me emphasize it even more. Would you agree that the sausage is curved? Right. This is the name they use for it, and I don't like this name. Curvilinear. I don't like that name. Shouldn't they just call it curved? Yeah, if you called it curved, I wouldn't have a problem. Why don't I like curvilinear? I don't like the word linear in the name. Doesn't it make you think it's straight? I just don't like the name. That's just personal. You might argue about definitely not weak. Would you agree these are not weak? Agreed? Moderate or strong, depending on your opinion. Oh, here's something negative and negative. Why does this one count as negative? As x gets bigger, doesn't the y get smaller, even though it gets smaller by less amounts? Isn't it still kind of going downhill? So if you want to think of negative, imagine that you're in the left-hand side of the shape. Aren't you sliding downhill? If you're sliding downhill, it's negative. And if you're going uphill, it's positive. That's how I tell positive or negatives. I don't care if it curves downhill or it goes straight downhill, right? It's still going downhill. It still counts as negative. And that is a real nice place for us to finish today.